we are looking now at the EL, the Institute for Lightweight Structures, from Professor Fraiotto. That's what I found when I went for the first time to the University of Stuttgart. What we are looking now is a measure table developed by Professor Fraiotto, and it was developed in order to mesh the geometry of a hanging model, for instance, like this one. This is a small hanging model I built by myself. It was my proposal. And I had to find the geometry of this grid shell. For that, I had to move with these instruments. I had to move in X coordinate, Y coordinate, or Z coordinate. I was able to do that with this thing here, red thing. And then I went with another instrument in each one of the nodes, and I go to 3 coordinates, X, Y, and Z. And I got printed the coordinates in these electro devices, and here they were printed. So as you can see, it was a very meticulous work. It took a lot of work, and mainly first we had to build a very precise physical model. Then when my doctor work was a proposal, how can you find the form without building a hanging net? And this is what I got. I found out that if you use a translation surface of two curves, in this case catenaries, what we see here is a hanging net, but upside down, but the geometry was previously determined with computers and geometry models. I will talk a little bit later up on that. And it was possible to find the geometry of the grid shell without the necessity of building a hanging model. And there are many geometrical properties in this surface, like for instance, 4 symmetrical nodes are on the same plane. So you can use, for covering the roof, you can use plane elements like glass, concrete, timber, whatever. And for that, I wrote a computer program. That was in 1980. It was a program for finding the geometry of a grid shell, but without building the physical model. The first version, I wrote it in 1980, and it was developed in Fortran 4. Fortran 4 is a language maybe for you have never heard it before, but it was the language available, a computer language, to write the program at that time. So I wrote the first program in 1980. 10 years later, more or less, Reinhard Kutten, he was a student of the University of Essen, wrote the program again. He made it more friendly to handle. And lately, Kevin Uriel, he's a student of the University of Mexico. He studies mechatronics. And last year, he finished a new version of this program that will be available for all students and professionals interested in form finding of grid shells with no cost. It will be free for everybody. And the program is written in Spanish as well as in English. Then, with this geometry, I will show you some projects with them I started my first works in architecture. This is a small grid shell for a one-family house, a timber grid shell. It is a space from 6 meters by 6 meters and 6 meter height too. And it is timber combined with glass. But with the geometry, the form finding was made with the computer program I had previously developed at the University of Stuttgart. A few years later, I had the opportunity of building and designing and building this another grid shell. It is a metal arches and glass, covered with glass. You can see the plain glasses to cover this garden. It is in the Faculty of Architecture at the University of Mexico. And then came bigger structures like this one. This is an auditorium for the government in Mexico. And this is a metal arches with timber. And in one place there was a window with glass in this place. And it was built about 1990, more or less. Here is another example. This is another grid shell. The design was not mine, but we had to build this shell. They didn't know how to build it. And this is not a translation surface. Therefore, it was not possible to use plain glass elements to cover that. And what we did was to separate each element in two triangles. You know that 3 points in space are always a plane. So we had triangles. We were able with these triangles to cover each one of the meshes of this grid. And another shell, this is a bamboo grid shell constructed at the University of Mexico. The project was made by the students of architecture. It's a diploma work from students of architecture. I just guided them with the form and so on. But it was a very interesting experience, and the students learned a lot of things, of new things with this shell that was only 3 months on this place. They had to dismantle. You know, the University of Mexico is protected the architecture, the heritage. We cannot build whatever we wish. So it was possible to build this grid shell only for 2 or 3 months, no longer that. But with bamboos, and what is interesting is that we use technology, but we use materials that are sustainable materials, that we should learn to use them more in our current architecture, not just thinking in metal, steel, and concrete. Although sometimes we cannot, we have to use some elements in metal, like you can see at the bottom of this grid shell. Then now let's change to membrane structures, textile architecture. This is a small membrane structure built. It is very easy to build it in just 4 or 5 hours. You can build it, you can dismantle it and take it away. And it is a multi-purpose membrane structure for the University of Mexico. It is still in use. We can take it to another cities in our country, and it works fine, and you can move it around, and it's like a module. You can put many together and to cover more area. And this one is a membrane structure for a historical building. This is the Palace of Mines, Palacio de Minería in Spanish. It is an old building, 250 years old, and we had to cover the roof, the main roof of this building. So it was a challenge because we had to respect the architecture of the old building, but to protect the roof from raining and sun. And so came this proposal from membrane structure. It was a contest at the university. And then here I worked with another 12 students and another professor. And we won the contest, and we were able to build this roof, and it works quite well. As you can see, there is no problems with the weather. It means it is not very hot when the sun shines. the roof is, the yard is protected, but the warm air can't go out through the sides of this membrane structure. And it is, if necessary, we can dismantle this structure in one day, and you don't see anything about that. It means that it is reversible, and the building, the old building, keeps his old architecture. That's the main thing in this building, the old architecture, not our roof. Our roof is just for a few years, not forever. And so we have made and designed many other roofs. This is just an example of what we have made, but in the professional field. But my main activity is working with the students, is research and teaching. And here we have the Lightweight Structures Laboratory at the University of Mexico. Here I am showing a model which will be built with bamboos to some other professors and to the students. You can see in the back the students, and this is the place where that I miss now on these quarantine days that we have to stay home. But I'm sure some days in the future we will be able to go back here. And as you can see, we are now working with bamboos and with bricks. With bricks here, you can see the students working with bricks fabricated at the laboratory, and also the models we are looking at now. Each brick was made and the students have a lot of fun, and they learn also a lot of things by doing these models. This is the last model slide. I show it because you can see membrane structures designed by students who have won international contests, students' contest. At the top of the left side, you can see a pyramid. Down, you can see an exhibition hall in Coyoacán in Mexico City. And on the right side, a restaurant with a foldable structure. As I said before, the two on the link side were won by students, international contests, and the right one also was built by a former student. It's a foldable membrane structure which is still working. You cannot read what you see at the top of this shield. It means let no one ignorant of geometry enter here. We put this shield at the entrance of the laboratory, but we added let no one ignorant of geometry and mechanics enter here. With this, we want to say that it is very important, the form and the force, geometry and mechanics. And therefore, when I teach my lessons, I introduced a new subject called mechametry. Mechametry is a mixture of mechanics and geometry. And with this term, I always try to teach the students both fields together. Not just geometry, not just mechanics, but mechanics and geometry. And with this, I will finish this second part of the presentation.